Hi, this is section 5.5 part 2, and we're going to look at example 3 part A and B here. And it says finding the following indefinite integral. If I look at this right away, I see that it's a quotient, and I'm not able to handle it with any of the rules that we currently have. So my guess is I'm going to have to use substitution. So the first thing we're going to do is rewrite this as ln of x raised to the third power, or 1/3 power, excuse me, over 5x dx. And then I can further rewrite this as ln of x raised to the 1/3 power times 1 over 5x dx. And the reason why I'm doing that is because I'm going to try to use substitution to be able to handle this. And I want this in the form of whatever I'm substituting times my leftovers. So my leftovers for this particular one is 1/5 or 1 over 5x dx. Okay. So let's work on that substitution. I'm going to go ahead and let u equal whatever's inside the parentheses, which is ln x. So I'm going to take the derivative of u and the derivative of ln of x, which is 1 over x dx. And I see that that doesn't quite match up to my leftover, which is 1 over 5x dx. So I know I can multiply by a constant. And in this time around, I'm going to have to multiply by 1/5 to get it to be 1 over 5x. So if I multiply by that constant, I get 1/5 du equals 1/5 times 1 over x dx. So that becomes 1/5 du equals 1 over 5x dx. Now my leftovers match. So 1 over 5x dx matches the original equation. So my next step is to rewrite the integral in terms of u. So I do the integral sign u to the 1/3 power, and now I'm going to write times 1/5 du. So I'm going to take the 1/5 out. So I'm going to do 1/5 of the integration of u to the 1/3 du. And now I'm going to integrate. So if I integrate this, I get 1/5 times u to the 1/3 plus 1 over 1/3 plus 1 is going to give me 4/3. So this is going to be over 4/3 plus c. Okay, so what does this look like? It's 1/5 times 3/4 u to the 4/3 plus c. 1/5 times 3/4 equals 3/20 u to the 4/3 plus c. The last thing I have to do is back substitute. Remember, we said that u equaled ln of x. So with that in mind, I just have to rewrite this as 3 over 20. Instead of u, I put in ln x. And this is raised to the 4/3 power plus c. So this is the answer for example 3, part A. Okay, so let's look at 3b. We have to find the following indefinite integral, integrate sine squared of 4x times cosine of 4x dx. And if you look at this, sometimes it'll give you a hint of what you need to substitute. Like right now, I can't do this problem, so I have to use substitution or try it at least. And I'm looking at that, and I know that if I take sine of 4x, I'm going to get pretty close, if I take the derivative of that, to cosine of 4x. So I'm going to try substituting in, let's let u equal sine of 4x. I'm not taking sine squared of 4x, just sine of 4x. And if I take the derivative of that, the derivative of u is du, and the derivative of sine of 4x is cosine 4x, and then I have to use the chain rule to integrate the inside, which is 4x, so that's going to be times 4. So du equals 4 times cosine of 4x dx. Okay? That doesn't 100% look like my leftover because I have that a 4 in front of cosine of 4x, but I know I can multiply by a constant to make them match. So if I multiply by 1/4, so I take 1/4 times both sides, that'll get rid of that 4 in front of the cosine 4x dx. And when I do that, I get 1/4 du equals cosine of 4x dx. Now my leftovers match. So cosine of 4x dx matches cosine of 4x dx. So my next step is to write the integration. So remember it said sine squared of 4x times cosine 4x dx. So this becomes u squared and then times 1/4 du. Okay, so I'm going to take the coefficient of 1/4 out. U squared du is what I have left. So substitute right. We're going to integrate next. So this becomes 1/4 times u, 2 plus 1 is 3/3 plus c. So this becomes 1/4 times 1/3 u to the third plus c. So I get 1/12 u to the third plus c. Okay, my last step is to use back substitution. Remember we said u equals sine of 4x. So wherever I see u, I'm going to plug that in. So my answer is going to be 1/12 sine of 4x cubed plus c. You could also rewrite this as 1/12 sine cubed of 4x plus c. Okay, so either or is correct. Okay, all right, let's look at the next one. Example number 4 says find the following indefinite integral, and I'm integrating x times e to the x squared du. Okay, so I'm looking at this, and if I rewrite this so that I have this in terms of a leftover, I would have integration of e to the x squared times x dx. Okay, so my leftover is going to be x dx. So if I'm looking at that, if I let u equal x squared, which is the power of e, then I take the derivative of that. So I take the derivative of u, which is du, and take the derivative of x squared is 2x dx. I almost have the leftover. What I have to do is get rid of that 2. So to get rid of the 2, I'm going to multiply by a constant, which is 1/2. So if I take 1/2 times both sides, that'll allow me to get rid of that 2, which gives me 1/2 du equals x dx. Now, this looks like my leftover, so let's check out. Okay, next step is to write the integration in terms of u. So once again, I have e to the u times 1/2 du. Okay, so I'm going to pull the 1/2 out front of the integration sign. So I have 1/2 e to the u du. And now it's time to integrate. Okay, so integration of this is pretty easy because the integral of e to the u is e to the u. So we get 1/2 e to the u plus c. Last step is back substitution. Remember, I let u equal x squared. So wherever I see u, I'm going to plug in x squared. So the answer is going to be 1/2 e to the x squared plus c. Okay, not too bad. Let's look at the next one. So now we have part B, which is e to the x over 1 plus e to the 2x. Once again, I want to write this as a product initially because I want to use substitution. So I need to have what I'm integrating times my leftover. So I'm going to rewrite this as 1 over 1 plus e to the 2x times e to the x dx. Okay, and now let's try to figure out, hey, what the heck do I let u equal? I have a couple of choices here. I mean, if I let u equal, so let's try this. Let's let u equal 1 plus e to the 2x. Let's see what happens and see if this works or not. If I do the derivative, I get du equals, and if I take the derivative of e to the 2x, it's e to the 2x, and then I have to use a chain rule on that power, so it's multiplied by 2. So du equals 2 e to the 2x dx. Okay? So does that work? I mean, I am allowed to multiply by a constant, and even if I multiply by 1/2, to get rid of the coefficient of 2, I'm going to get 1/2 du equals 1/2 times 2 e to the 2x dx. I still have problems here, and the reason why is because my leftovers do not match up. E to the x dx does not match up with e to the 2x dx, so this doesn't work. So that substitution doesn't work. So we got to figure out something else, start over. And this will happen sometimes, guys. So if we start over, if we remember from section 4.8, if we remember that 1 over 1 plus x squared equaled the inverse tangent of x plus c. So if we integrate 1 over 1 plus x squared, we get inverse tangent x plus c. So maybe we could write this up so that it works out right. So we rewrote the problem okay. But if I look at this original problem, if I do this, 1 plus e to the x squared, or let me rewrite that. If we take e to the x here and we square it, we'll get e to the 2x, right? And that almost looks like this. It almost looks like that. So let's try using substitution here, and let's let u equal e to the x. If I do that, I take the derivative of u equals du, and if I take the derivative of e to the x, it's e to the x dx. Now check that out. My leftovers match up to the original problem, right? I should have put e to the x dx over here. Okay, so since I got the leftovers to match up, my next step is to write the integration in terms of u. So what I get is 1 over 1 plus u squared times du. Okay? So we just discussed that 1 over 1 plus u squared, if I take the integration of that, I'm going to get inverse tangent of x, or u this time, sorry, of u plus c. Okay? All right, so your last step is to back substitute. So remember, we let u equal 1 plus e to the 2x. So what does this become? This becomes the inverse tangent of 1 plus e to the 2x. Or sorry, it's the substitution was e to the x. Sorry about that. Let's back up a minute. U does not equal 1 plus e to the x. U equaled e to the x. Sorry about that. So using back substitution, I get inverse tangent of e to the x plus c. There it is. Okay? So this problem was a little bit more difficult, but remember, some of the inverse functions might let you be able to use substitution. So, look out for something that looks like this. So at least you have this in your notes. When you run into something like this on my math lab, you know what to do with it. All right, so let's move on to example number 5. Find the following indefinite integral. We have 3x over the square root of 1 minus 9x to the 4th dx. So once again, I want to rewrite this original problem because I know I'm going to have to use substitution because it doesn't look like anything we have. So if I rewrite the problem, I get 1, shoot, why does it keep on jumping like that? 1 over the square root of 1 minus 9x to the 4th, and then times 3x dx. Okay, so what do I let equal the substitution? So if I look underneath the radical, I can say, okay, well, I can go after that, and then I have 1 over u to the 1/2 power, but let's see what happens. So let's try this. If we substitute, let u equal 1 minus 9x to the 4th, du equals negative 36x to the third dx. Look at the power of my leftover. The power of my leftover is 3x dx. That doesn't match this. So I know I haven't done the correct substitution. So let's go ahead and erase that because that didn't work. And let's go back and try again. So we don't quit. We try again. If I look at this, I remember from 4.8. So let me remove the s. So I remember from 4.8 that the integration of 1 over the square root of 1 minus x squared dx is equal to inverse sine of x plus c. So since I have that, that almost looks like what I have here. So why don't we write the 9x to the fourth as something squared? So if I rewrite the original as 1 over the square root of 1 minus, 9 is a perfect square, it's 3 squared, and x to the fourth is a perfect squared, it's x squared. So if I rewrite it like this, I might be in luck. So this time around, let's substitute. Let's let u equal 3x squared. And if I take the derivative of u, I get du. And if I take the derivative of 3x squared, I get 6x dx. That almost looks right, because now I can multiply by a constant. And the constant is going to be 1/2, because if I multiply 6 by 1/2, I'll get 3. So if I multiply the left-hand side by 1/2, I get 1/2 du. And if I multiply the right-hand side by 1/2, I get 1/2 times 6x dx. So 1/2 du equals 3x dx. Now I'm in good shape because my leftovers match up. So my next step is to write out the integral in terms of u. So I'm going to write this out as 1 over the square root of 1 minus u squared. And then I have times 1/2 du. So if I take and place the 1/2 outside of the integration sign, I get 1/2 times the integral of 1 over 1 minus u squared du. Now it's time to integrate. So remember, we just said that the integration of 1 over the square root of 1 minus x squared dx is inverse sine x plus c. So this becomes 1/2 times the inverse sine x plus the constant. And remember, this is supposed to be u because we haven't back substituted yet. Which brings me to the last step, back substitute. Remember, u equals 3x squared. So I'm going to write, wherever I see u, I'm going to put in 3x squared, and then we'll call it a day on this one. So this becomes 1/2 inverse sine of 3x squared plus c is my answer. Okay. All right. And then I'm going to stop here, and there's going to be one more video, so you will have a 5.5 part 3.